This video shows the solution of the maths problem known as Hannah's Sweets. The question has been in the news recently because people thought it was too hard for GCSE level. I personally don't agree, and I'm going to show you how to arrive at the solution using methods that most GCSE students should be familiar with. So here's the question. There are n sweets in a bag. 6 of the sweets are orange, the rest of the sweets are yellow. Hannah takes a random sweet from the bag. She eats the sweet. Hannah then takes, at random, another sweet from the bag. She eats the sweet. The probability that Hannah eats 2 orange sweets is 1/3. Show that n squared minus n minus 90 equals 0. One reason why many students found it hard was that it brings together two different branches of maths, probability and algebra. Let's start with the probability. But before tackling the problem as written, there are a couple of simple probability rules you need to know. Let's say there were 5 sweets in a bag, 3 orange and 2 yellow. If Hannah chooses a sweet at random, what is the probability that her first sweet is orange? Well, there are 3 orange sweets out of a total of 5 sweets. She has a 3 in 5 chance, and this is normally written as the fraction 3/5. And now what about her second choice? Remember that one sweet has now gone, an orange one. So the bag now contains 4 sweets, of which 2 are orange. So this time her probability of choosing an orange one is 2 out of 4, or 2/4. But the question deals with the probability that both sweets are orange. And you need to know a basic rule of probability, which is that you can calculate the probability of 2 events both happening by multiplying the separate probabilities of each event. In this case, the probability that both sweets are orange is 3/5 times 2/4. This comes to 6/20, and you can simplify it to 3/10. And that's all the probability theory you need to know. Let's turn now to the actual question. There are 6 orange sweets. The actual number of yellow sweets is not known, but there are n sweets altogether. So the probability that the first sweet is orange is 6 divided by n. Hannah eats this sweet, so there are now n minus 1 sweets left, of which 5 are orange. So this time her chance of picking an orange sweet is 5 divided by n minus 1. And the final step, what is the probability that both sweets are orange? As before, just multiply these two probabilities. 6 over n times 5 over n minus 1. And that comes to 30 over n times n minus 1. Now, this might look like the end of the road, but it's not. You need to remember something that you've already been told in the question, which is that the probability of Hannah's sweets both being orange is 1/3. This is the point in the question where the probability stops and the algebra takes over. This expression, 30 divided by n times n minus 1, must be equal to 1/3. We now have an equation, but is it the same as the one in the question, which was this? N squared minus n minus 90 equals 0. In fact, it is the same equation, but you need to do a bit of algebraic messing around to turn my equation into the target equation shown here in red. Remember, the golden rule with fiddling about with equations is that whatever you do to one side of the equal sign, you have to do to the other. The first thing I notice is this 3. So, step 1, I can get rid of it on the bottom by multiplying both sides by 3. These 3's cancel, and you get this. 90 over n times n minus 1 is equal to 1. Next, I see this n times n minus 1. So, step 2, I can get rid of it on the bottom by multiplying both sides by n times n minus 1. And again, these cancel, leaving this. 90 equals n times n minus 1. And now my equation is starting to look a bit more like the target equation. For step 3, I'll do a bit of rearrangement. First, I'll multiply out the brackets. So the right-hand side of the equation becomes n squared minus n. I can subtract 90 from both sides to get this. 0 equals n squared minus n minus 90. And finally, I'll just swap the two sides over to get the target equation. And that's it.